Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have count subarrays where max elements appears at least k times. So on the problem statement they have given an integer array nums and positive integers k. Now we have to return the number of subarrays where maximum elements of nums appear at least k times in the subarray. So we have to return the count. We finally have to return the count of subarrays where maximum elements of nums appear at least k times in that subarray. A subarray is a contiguous sequence of the elements within an array. I think the problem is very short and crisp and clear also on the first read. So now if we can go through the test cases also. So here you can see this is the nums array they have given, and they have given a k factors with 2. So now we have to find how many subarrays where what is the maximum elements of this array. It is nothing but 3. So in the subarray 3 occurs at least 2 or more than 2 times. So here you can see like there are the subarrays that contains the elements 3 at least 2 times are this. So this 6 subarrays where you can see like 3 occurs at least 2 times or more than 2 times. So these all are valid subarrays. On this example you can see for k equals to 3, 4 is what is the like largest elements of this array is 4. Now you can't select any subarray where 4 occurs at least 3 or more times. So on that case the output is 0. Yeah, I think the problem is very straightforward, and with the test cases also it's very clear. And now on solution build you can see the constant is very big, like 10 raised to the power 5. You can't generate all the subarrays with L and R pointer, like 2 for loops, basically executions of 2 for loops, one going to be iterated from 0 to n I, and your j loops is going to be iterated from I plus 1 to n. Like this way you can't generate all the subarray. That is bound to give you an DLE. And now I think from last 1, 2, 3, 4 videos or maybe more, like if you are following our sliding window playlist, like this is very intuitively we like blindly after solving how many problems we altogether solve on sliding window. Let me check it quickly. So here you can see like on sliding window we almost solved 10, like altogether solved 10 videos of sliding window. And this problem is, if you are guys, I am repeatedly stating, please go through the playlist once. Like I think our playlist is almost enriched with all the different topics, toposort, tree, dp, heaps. For that topics I think very less videos, but at least the playlist for which there are 5 or more videos. So sortings, graph, then sliding window, so definitely binary search is definitely maths. So please go through this playlist at least like one time, so that like after getting you will feel like you don't have to need any solutions altogether. You just need to write the template and you are going to get an ace. So I think when I repeatedly mentioned on the last videos, when we have subarrays where I pointer is moving on this way from 0 to n. Now we can go to our OneNote. So where if I consider a subarray, so here you can see, are we writing? Give me 1 minute. Space test is working. Space test. What happens? Why it is not going to run? Started. Okay, I guess now it started. Yeah, so where we are, yeah. So now if you can understand it, right? So if you can understand it correctly, so where we have these things, we on now, so if that is an array A, B, C, D, E, F, and when we are running this kind of things, we are running an I loop from 0, I is going to be running from 0 to n, and your J loop is going to be run on I plus 1 to n, and you are considering a window of size I to j. When this is very standard template, so when you are running like writing code something like on your root is looking like something like this, then please apply our template at least 1 times, and think of that sliding window template at least 1 times to apply a two pointer of sliding window if it is going to be fit on this particular window. So here very straightforwardly, if we are trying to apply our sliding window template, then our R pointer is going to be iterate from 0 to n for sure, and our L pointer is going to be start our L pointer is going to be start from 0. So L is going to be move point to here. So if how we can apply our template, how we can see for an arbitrary value of R index where we are standing. Let's suppose we are standing at this particular index, Now what we are looking for? We are basically looking for our L can be here, our L can be here, our L can be here at any index. So we are looking for a first invalid L where the window that we are considering. So for this particular R, one window can be itself, one window can be this CD, one window can be BCD, another window can be ABCD. So if our L is pointing to 0th index, now we have to move our L pointer, at certain index, where L2R window that we are considering, L2R window that we are considering is invalid. So can I say, so now let's suppose we shrink our window by moving our left pointer, to, let's suppose C and D, and let's suppose our largest element is nothing but X, and which of the elements are equal? Let's suppose B is equal and D is also equal, both are also equal. So this is one max element, and let's suppose K factor is given to 2. So on this particular window, how many largest factor? Only D. So we are only getting one largest elements. But with this window it is valid. Can I say to this window it is also valid? Yes, we on that window also we have B and D. So can I in general say from this left to all of its index, from this particular IDX to index 0, all are valid. Yes, definitely I can say, because we are increasing our window. Then from R to L, we can move our L to extreme left. So our window is going to be expand. So the chance of getting max elements is more, right? And we have to taking care of at least K. So that is the smallest window from this particular R. This L is the smallest L where this window is valid, So can I say from this to all of its left are valid, Yes, definitely. So that is exactly our template. So we have to move our L pointer. When it is valid, we will try to shrink, and when it is just land to the index where it is first invalid, then we can say from this L to all of its left are valid. So here you can see if I index them 0, 1, 2, 3, right? So from this part, if maybe I can write clearly here again, that is more hazy kind of things. C, D, E we can neglect. So our R pointer is here and our left pointer is here. So this from here to all of its left are valid. So how many then valid? So this one is a valid answer, this one is a valid answer. So if I can name it to the index 0, 1, 2, 3. So where our left pointer is standing, as index is 0 based, so can I add whatever the left pointer is currently starting? So L pointer after shrinking your window, after shrinking, L pointer points to first invalid index of L2R. So left, just left of L to all left are valid. Yes, exactly. Yes, agree. So how many then valid? Here 2 valid, one this one this, and L pointer is standing to 2 as index is 0 based. So if you add answer plus equals 12, so that means L is pointing to first invalid index, which is nothing but pointing to how many you can consider of its left, to its left. Very intuitive. As index is 0 based, you can directly add to L number, or if you can write it like how many elements, like if you can write it, so you can consider L minus 1, then minus, so that is your this boundary, this boundary to 0 plus 1. So 1 gets cancelled and it is nothing but L. So that's the reason you can directly add to answer plus equals to L. Now I will just quickly write the pseudocode for you. So it is very simple, guys. The standard template we are following. See how fast I can write it. We will write to for R in range N. If nums of are the elements that we are considering is equivalent to our max elements. Maybe we are storing our max variable. Obviously, we are storing our max mx variables to somewhere above the execution, and if it is so, then we are increasing our counter plus plus. And what else is pending? And if any particular time, if our counter is more than equals to k, now we have to shrink our L pointer to point first invalid index. Now, if again just reverse, what we have to do? Just reverse of expand. So that is of your expand, and that is of your shrink. So on shrink you have to do just reverse. So here you have to write if nums of L equals to mx. So there on the expand you have increased your counter, here decreased your counter. That's it. And increase your left pointer to plus plus. Exactly this. And finally after this while block execution you can increase your answer plus equals to L. Right? And finally you can return your answer. Yes, that's it for this particular solution. Yes, now we can quickly discuss the code iterations of our submissions. Sorry. Yes, so I have initialized all the variables. N we need the length of the array, left pointer, answer, mx, count. All are len of nums. L is 0, answer is 0, mx is max of nums, and our count is 0. Now we are moving our right pointer. If nums of r equals to mx, expand by increasing the counter, and if counter is more than k, so that means we already got some window. Let's shrink to make L2 where L2 stand to first invalid index. So we are doing shrinking nums of L is equals to max, count minus equals to 1, and we are increasing to L. And finally after this while loop executions, we know our L is pointing to some index from just of its left to all till 0 index. We can consider all of them, and we have defined the formula L minus 1 minus 0 plus 1, and 1 gets cancelled, so you can directly add answer plus equals to L, and finally you can return your answer. That's it, guys. That's it for this particular video. And now if we can, so what we have used, see guys, we just used our own template that we are like repeatedly explaining from last 3 to 4 videos, and on sliding window I think so all the 10 videos we are explaining this template. And if you are feel at any point you are not able to grasp exactly, or not able to feel the particular submission, or not able to grasp the entire intuitions is not going to fit on your brain, please, I will definitely going to request repeatedly, I am requesting you, please go through like at least 5 videos, first 5 videos of sliding window. There are 10 videos, and including this it is going to be 11 videos. I'll repeatedly requesting guys, please go through at least first 5 videos. Then this type of template, when you are able to digest, and template is fit on your brain, then this code you are seeing that too, yeah, don't have to see you at all. We can write like in 2 to 3 minutes. So that's the reasons I am repeatedly stating the same things. Yeah, now we can quickly discuss the time complexity. So on time perspective, we all know this particular submissions time complexity is all the time is big of 2. Why so? Because our left pointer is going to visit all the elements at max 1 time, right pointer is going to visit all the elements at max 1 time. So every element can be visited by at max 2 times, once by left pointer, once by right pointer. Yes, definitely yes. So the time complexity of this particular code block is big of 2n for sure. But please take a note, small note here, we are using max of nums, and so this max functions is obviously going to iterate to all the nums, that is of inbuilt functions of Python. Every language already have it, but this max functions you can check on GPT or Google it. This bound to take a big of n time complexity, because it is going to iterate all the elements, and it is going to find if it is the max elements altogether, of the nums. So this is also going to be take a big of n for sure. So final time complexity, this code block big of 2n, this max functions plus big of n, it is going to be at, so final time complexity of our submissions is big of 3n for sure. And see guys, how clarity with how small granular level clarity I am explaining the time complexity. I am like considering each functions I am using, each inbuilt functions I am using, I am have that level grip of that functions, inbuilt functions I am using. So please build your grasp on this particular, every functions you are using, inbuilt functions of the particular language you are using. If on an interview, if interviewer going to ask you to write your own functions, not using that particular functions, so if you have that level of clarity, so then you can exactly pinpoint your time complexity on your interviews. That actually make yourself different from the other candidates. Other candidates maybe like after seeing my videos, Shouvik's video, they are also maybe write this template, but maybe on that particular template there can be more time complexity. This is the for sure big of 2n, but this type of functions that can be a problem specific. If we are using, then maybe some candidate is going to be missed. So I am basically making sure that please set yourself to like that bar. If anything happens, no matter to anyone is going to reject you, as you have show your clarity of particular topic on that level. So that's the reasons. Write your time complexity not on the big O terms, on exact granular terms. So big O of 3n, big O of 4n, 5n, n log n, this kind of things. Not n log n, 3n log n, 4n log n, 5n log n, this type of things. And on space perspective, do you guys see we are using any extra space? Nope, nope, nope. All are variables only. So on space perspective, we are super good. We are using constant space, big O of 1. And yeah, guys, so that is bound to be the most optimal solutions for this particular submissions. Mine one is more than 90 to 95%, somewhere faster than all the submissions. So yeah, that's it for this particular video. And if you guys are able to understand till this point, please do subscribe to our channel, and please share the videos to your friend circle who are also preparing for top product companies and also brushing up their TSS. And please turn on the notification so that when we are going to be live to our next video, you will get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.